Hi everybody, my name is Professor Rad, and today we're going to multiply fractions by using a very straightforward technique. In the next video, we'll look at a little bit more of a roundabout technique, and the two techniques have their pros and their cons. In my classes, either one is acceptable, but as we talked about when we first did addition and subtraction, multiplying and dividing and stuff, you want to give each of them a chance just to kind of see, which one you might like better, which fits better with your flow. So this technique that we're going to do today, the advantage is it is super straightforward. So you just do what you need to do, you multiply, and then you simplify. That's the technique. The downside to this method is if your numbers are large, it's very difficult to do by hand and really easy to make mistakes. And it can be difficult to know whether or not you should continue to try simplifying if some of those factors to simplify are pretty big. So let's go through. We'll work through the first two examples completely by hand, so you can kind of see how this might get tricky if the numbers were bigger. And then the third example, we'll use the calculator to help us do the multiplying. So just to reiterate, Theorem 2, to multiply fractions, you multiply the numerators, multiply the denominators, and then you simplify if it's possible. In the last video, we also talked about what multiplication looks like and why this is the technique. So if you're curious about, well, why you do that, when addition you need a common denominator, you don't need one for multiplying, you can check out the last video to see why. Okay, so for our first example here, example A, we're going to multiply 5/7 times 4/25. So we're going to multiply across the top and across the bottom. So 5 times 4 is not too bad. I know that's 20. But 7 times 25, I'm going to work that out on the side. And I'm going to use the traditional method for this. So 7 times 5 is 35. Carry over the 3. 7 times 2 is 14. 15, 16, 17. So we get 175. Cool, so that's the multiplying part. Just go across the top, across the bottom. But you can see if our denominator here instead of 7 had been 71, 71 times 25, this would have been a tougher process. And if our numerators were pretty hideous numbers, that would be kind of terrible to do by hand as well. Now we have to simplify. So you want to think about your different simplifying techniques. I'm noticing that the top ends in a 0 and the bottom ends in a 5, which means 5 is going to be a factor for both of these. Now remember, I'm doing this one by hand, so I'm going to do that dividing by hand as well. Now I know 5 goes into 24 times, that's not too bad, but 175, I'm going to break that off on the side and do some long division. So 5 doesn't go into 1, it's too small. 5 goes into 17 3 times, since 3 times 5 is 15. When I subtract, I get a 2, and then I can bring down this 5. 5 goes into 25 5 times, and 5 times 5 is 25, and as I hoped, there's no remainder. So that means 5 goes into 175 35 times. Now, it looks like 5 was the GCF of 20 and 175 because no other number is going to go into both 4 and 35, other than 1, of course. So that means this is going to be our final answer. Now let's go ahead and look at the next question. So this next one, we have 3/14 times 7. So one of the things I noticed straight away here is that I've got a fraction times a whole number. So to make this a little bit easier to conceive, I want to write that whole number in fraction format, so that way I know that I can multiply the numerators and then multiply the denominators. Remember that any whole number can be written as a fraction by putting it over 1. So I'm going to write this as 3/14 times 7 over 1. And this is because 7 divided by 1 is the same as 7. So we can put that 1 in there to help us multiply. Now both of my numbers have numerators and denominators, so we can multiply across the top. 3 times 7 is 21, And across the bottom, 14 times 1 is 14. Now we can go ahead and see if our fraction simplifies. In this case, I know that 7 is a factor of both 21 and 14, so we can divide the top and bottom by 7. Simplifying is a lot easier if you know your multiplication tables, but if you don't, then you can go ahead and use your calculator to help you divide to find some factors. 21 divided by 7 is 3, and 14 divided by 7 is going to give us 2. So it looks like 3/14 times 7 is going to give us 3/2. All right, so these two problems had numbers that weren't super big. Let's go ahead and look at a problem where the numbers aren't giant, but they are still big enough to make it a headache. All right, so we're going to look at 33/34 times 85/99. And you know what? I said I was going to use my calculator to help me out on this one, but I do want to see, kind of work through the agony, because I want to see if I actually like this method. So I'm going to work this one out by hand, and then I'll use my calculator to check my multiplying before we go to simplify, just to make sure that we're kind of checking along the way. So we're going to multiply the numerators and the denominators. So let's do 85 times 33. I'm going to use the traditional method for this one. 3 times 5 is 15. And 3 times 8 is 24, plus 1 is 25. Now, on the next line, this is one of the common mistakes I've noticed about those using the traditional method. You want to make sure when you move over one digit here, on the next line, you put a placeholder 0 as well. And then you can go ahead and multiply. 3 times 5 is 15, carry the 1. 3 times 8 is 24, plus 1 is 25. Then we add up those results. And we get 2,805. So let's check that. 33 times 85, 2805. Great. So my numerator here is 2,805. All right, now let's go ahead and multiply the two denominators. So we have 34 times 99. I'm going to put the 34 first this time, just because I kind of like that I'll be multiplying by the same digit on the bottom. So 9 times 4 is 36. 9 times 3 is 27. 30 when I add the 3. Put down my 0 placeholder since I'm going over to the next 9. 9 times 4 is still 36. And 9 times 3 is still 27. Plus 3 is 30. Now we can go ahead and add these up. We got a 6 and a 6, 3 and 3. So it looks like 3,366. So let's check. 34 times 99, 3,336. Beautiful. Oh, 66, sorry. 3,366. Okay. Next, we're going to see if we can simplify this. So when I look at the top and the bottom, nothing immediately jumps out at me. The things that immediately jump out usually are things like 5s or 2s. So the top I know is divisible by 5 because it ends in a 5, but the bottom's not because it doesn't. So I know 5 is kind of a useless attempt here for a factor. Also, I know 2 is kind of a useless attempt because the bottom is even, so 2 will work here, but it won't work up top. So now I gotta try and figure out how I want to simplify this. I could try to simplify by trying to continue to find common factors, or I could find the prime factorization of both the top and the bottom numbers. So you kind of want to pick your poison. Which method would you like to do? On this one, I think I'm gonna just keep trying different factors and see what we get. Okay. So what I'm going to do to help me out, since these are very large numbers, is I'm going to write out at the top a list of prime numbers that I could use to check. So we could try 2, 3, 5, 7, 9 is not prime because 3 goes into it, 11, 13, 17. Let's just try those to start out with, and we can look at more if we need to. As I've already mentioned, 2 is not going to work because 2 will go on the bottom but not the top. And 5 isn't going to work because it won't work in the bottom. Now let's try 3. So 2805 divided by 3. That worked out because we didn't get a decimal. And then 3366 divided by 3. That one also worked out since, again, we didn't get a decimal. So I'm going to divide the top and bottom by 3. And that's going to give me a 935 up top and an 1122 in the bottom. Now, just because the 3 worked one time doesn't mean I'm going to cross it out. I want to see if maybe it works again. So let's try 935 divided by 3. So 3 won't work anymore because I got a bunch of decimals. So I know 3 is not going to work to help me simplify. So now I'm going to move on to the next number on my list. 935 divided by 7. Okay, 7 doesn't work because it's a decimal. So now I'll try the next number, 11. 935 divided by 11. Okay, that one worked because we got 85 in the end. So now let's see if 11 also works in the bottom. 1122 divided by 11. Oh, sweet, it also works in the bottom. So we can divide the top and bottom by 11. And that gave me 85 up top and 102 in the bottom. Okay. Now let's try 11 again and see if we can break these down by 11. So 85 divided by 11. Nope, I get a decimal. So I'm going to cross out the 11. Let's try 13. 85 divided by 13. Nope, that didn't work either since we got a decimal. So we'll try 17. Oh, when we divided by 17, we got 5. So let's see if 17 goes into the bottom. Oh, hey, it did. And we got 6. So it looks like we can divide the top and bottom by 17. 85 divided by 17 was 5. And 102 divided by 17 was 6. Oh, I'm off the screen here. Okay, so it looks like that's going to be it because I know nothing goes into both 5 and 6 other than 1. So we end up getting 5, 6 as our answer. Now I do want to point out it was 100% coincidence that I just stopped at 17. I didn't know how far I was going to need to check. So if 17 didn't work, I would have continued to try and find some other factors. I was also toying with the idea of seeing, well, how many times 5 went into 85 to see if that would help me find a possible factor for 102. So sometimes it can be a little bit challenging to know how far to go, when to stop. And sometimes, like, you might have seen this 85 over 1 and 2 and thought, yeah, that's done. I mean, there's nothing that goes into it. So keeping track of the prime factors you've checked. Once you check a prime factor in the big number and it doesn't work, it's not going to work in any of the smaller numbers either. Because if I'm a factor of, say, 85, since 85 was a factor of 2805, any factor of 85 had to also work up here. So once you find one that doesn't work in the big number, you can cross it out and you don't have to check it anymore. And checking only the primes kind of helps you cut down the number of numbers you need to look at. All right, so we've got a few problems here for you to try out on your own and see how you do. So find each of these products and then simplify your answers. In the next video, we're going to work through the same exact examples, but we're going to work through them in a less direct way. So as we saw, especially for part C, finding our result through the straightforward technique made it a little bit challenging to simplify in the end and a little bit difficult to do by hand. So in the next video, we'll see if the other technique fits the way you think about things a little bit better. And if you like this technique, great, you can use this technique, no problem with it. All right, have a wonderful day, and I'll see you next time.